Somewhere far away in the boundless reaches of the universe, there's a region of space so large and empty that it defies imagination, a cosmic void. This vast expanse stretches across 1 billion light-years with scarcely a trace of matter. Mounting evidence suggests that we are likely floating within a cosmic void of about the same size. This region is incredibly vast, enormous beyond words, although in truth, language falls short of capturing the magnitude of this nothingness. It is within these voids that the true nature of the universe's structure and evolution can be discerned. Moreover, Earth, our home planet, is quite insignificant in the grand scheme of things. Once believed to occupy the hallowed center of the universe, our planet is now known to be just one among billions upon billions. In the depths of the night, as we gaze at the stars, we see galaxies, constellations, and celestial beauty. However, we seldom consider the immense voids that lie between them. Cosmic voids, vast regions of seemingly empty space, are some of the most enigmatic and fascinating structures in the universe. Though they may appear barren, these voids hold crucial information about the large-scale structure and evolution of the cosmos. By sheer volume, most of our universe is simply nothing, and when it comes to understanding the universe, this nothing holds immense power. This emptiness possesses a secret influence that subtly shapes the distribution of galaxies and the movement of cosmic matter. Therefore, one should not ask, is there any void? But rather, is there anything apart from the void? Our home galaxy, the Milky Way, is just one of billions in our universe. It resides within a complex environment shaped by various cosmic structures, including nearby voids. Understanding our place in the universe requires an appreciation of the intricate interplay between these structures. Evidence suggests that our galaxy is inside a cosmic void, a vast expanse of relatively empty space. The surprising aspect is that, according to the laws of cosmology, such a giant void shouldn't exist in the first place. The cosmological principle, a fundamental theory of cosmology, posits that matter in the universe should be uniformly distributed on very large scales. This principle underpins many of our cosmological models and our understanding of the universe's structure. However, multiple observations over the past decade suggest that matter in the universe may clump into regions of high and low densities, meaning it may not be as uniform as previously thought. To understand voids, we need to zoom out far beyond the solar system, the Milky Way, and even beyond the groups and clusters of galaxies nearby. We need to zoom out so far that entire galaxies, each with hundreds of millions of stars, look like tiny dots of light. At this vast scale, an amazing structure emerges. Galaxies are not scattered randomly. Instead, they form the largest pattern in nature. We see dense clusters with thousands of galaxies and long, thin strands connecting these clusters like highways with galaxies along them. These strands come together to form broad, immense walls, the regions that contain the typical cosmic mean density of matter. We call this vast structure the cosmic web. It's made of galaxies, much like your body is made of cells, but scaled to an unimaginable level. Voids now occupy over 80% of the universe's volume, but hold less than a tenth of its mass. The bright stars and galaxies of the cosmic web highlight the edges of these vast, empty regions. These cosmic voids dominate the universe, meaning most of it is nearly empty. Within these voids, you might find a few small, dim dwarf galaxies and a thin mix of radiation and particles. Yet, they remain largely empty, devoid of significant structures or matter. The seeds of voids were planted in the earliest moments of the universe, even before the first stars and galaxies. Billions of years ago, the matter in the universe was almost perfectly uniform, with only tiny random differences. Just 1 million more matter here or 1 million less there. However, within this uniformity, there existed minute-random fluctuations, tiny variations where there was a slightly higher concentration of matter in one place and slightly less in another. These minuscule differences played a pivotal role in the formation of structures we observe today. As the universe aged, these differences grew. Gravity, though weak, is persistent and patient. Regions with a bit more matter had a slightly stronger gravitational pull, attracting more matter and emptying their surroundings. As more matter gathered, the gravitational pull grew stronger and the surroundings emptied even more. Over hundreds of millions of years, the cosmic web began to form, first as small clumps that ignited the birth of early stars, then as small galaxies that merged together, eventually forming the great clusters of galaxies, the filaments, and the walls. The cosmic web represents the grandest pattern discovered in nature, extending throughout the entirety of the universe. It forms an immense and expansive structure, almost overpowering in scale. Yet its appearance is delicate and fragile, like fine strands of silk. As the cosmic web flourished, so too did the voids. They began as small, subtle dips in the otherwise uniform fabric of the universe. Over time, these voids expanded as their contents gravitated toward larger, luminous structures. Cosmic voids are akin to holes in the universe, resembling gaps in Swiss cheese or the openings in a spider's web. Stretching hundreds of millions of light years across, these voids are the true deserts of the cosmos, almost entirely devoid of matter. This emptiness holds a mysterious influence. In the late 1990s, when astronomers discovered that the universe's expansion was accelerating instead of slowing down under gravitational pull as expected, it was a profound revelation. This phenomenon, confirmed by multiple experiments, is attributed to dark energy. Dark energy remains an enigma. Scientists speculate it's a fundamental property of space-time itself, driving universal expansion. Locally, however, its effects are masked by the gravitational pull of stars, gas, dust, and other matter in our vicinity. But in the voids, there's nothing to counteract dark energy's influence. They expand relentlessly, pushing against the surrounding filaments and walls, perpetuating their growth. On a grand scale, the universe resembles a sponge, with voids dominating its vast expanse. Some voids span hundreds of millions of light years in diameter. To study these voids, astronomers rely on optical and radio telescopes to search for any signs of matter within them. Superclusters of galaxies and voids are frequently studied in tandem, as they are thought to share a common evolutionary history and dynamics. Our own Milky Way galaxy lies in a void called the KBC void or local hole. Other notable cosmic voids that have been discovered and studied in detail include the southern local supervoid and the Eridanus supervoid. However, none is as big as the Boötes void, sometimes called the Great Nothing or the Great Void. The Boötes void is a spherical region located approximately 700 million light-years away from Earth in the constellation Boötes. Boötes is depicted as the herdsman in Greek mythology. The Boötes void stretches across an immense area, spanning 330 million light-years, distinguishing it as the largest known void in the universe. Despite